Hello guys, today I am going to perform Owen's this experiment. In this experiment, I want to determine the self-inductance of unknown inductor. So here unknown inductor is given. I don't know what is the inductance of this inductor. So with the help of Owen's bridge, we can determine the inductance of this inductor. So for that, let us revise the thing about inductor. So basically, what is inductance? So I give you definition of inductance. The ability of inductor to give you EMF by changing a current. So let us derive an equation. What I am giving current, that means it's a di with respect to time. Di I am giving you current, and inductors give us EMF, but the ability is given by L, and here is minus. This is the equation for inductance L, and the unit of inductance is Henry. Unit of inductance is Henry. Henry is very large unit, but normally we have using millihenry. But I want to calculate this inductance. With the help of Owen's bridge. So for that, I have Owen's bridge. Let us check the circuit diagram which we want to use. So Owen's bridge basically have 4 arms. If you know value of component at 3 arms, then you may calculate 4 arms. Then you may calculate remaining arms value. That means, suppose guess that there is 4 arms and you know the value of these 3, then you may calculate the value of 4 arms. Let us check the circuit diagram and then we will go to the instruments. Yes. So in this circuit, there is a 4 arm and it's a bridge like. Circuit. Here is an inductor, and here is a variable. Here is a variable resistor, and here is a capacitor. It is a variable resistor. Inductor is given by L, and this resistance is given by Q. And here we are using a resistor, and it is a R. Here is another capacitor. Okay. Here this capacitor is C2. This one is C1, and then here we have another resistor. This is a P. Here is a null detector. So what I am using D. Okay. We are giving AC signal, so I place AC source here. Okay, so this is the basic circuit diagram. Here we are using detector. So I have null detector instead of null detector, digital null detector, you may use headphone also. Okay, good. So there are 4 arms. This is 1, 2, 3, and it's a 4. There are 4 arms here. For balance condition, you can check. Suppose the current direction of current flowing is this. This is the direction of flowing of current. Now check from here. There is a 2 part. One is here and second one is here. And now focus on this detector. Suppose here is detector. Detector is detect signal when the potential difference between these 2 points. Potential difference between these 2 points is captured. That means suppose here is 5 volt and here is 3 volt. Then there is a difference between this point is 2 volt. That means they observe difference between these 2 points is 2. Suppose you place here any lamp, then lamp will glow because potential difference is applied. When lamp turn off, whenever there is a balance condition, there is a 5 volt and there is also 5 volt, then lamp will not glow. So for that, I have derived an equation for balance condition. You can give the equation L is equals to PRC. L is equals to PRC. That means for L is a value of inductance that I want to find. Then P is a value of resistor. What is R? R is also value of resistor. But observe here, there is not only R, there is a capacitor also. There is a capacitor also. Okay, that means I have to use a capacitor also. There is a C, value of C is here. Here 2 capacitors is given. One is here and another one is here. But at a time we will use only one capacitor. And then focus here. Here L and Q also. The resistance of this Q will also need to include in this balance condition. But we will do something that will give us R. That means the value of Q is included in R or P. Okay? Good. So this is a circuit diagram. So let us go to the instrument and check how circuit is working and how will we take reading and perform the experiment. Okay, let's go. Okay, so here you can see there is a Owen's bridge instrument. Okay, let us turn on the switch. Okay, so here detector is given and the signal of digital detector will output here. Okay, so in this instrument here, as per we discuss in circuit diagram, here L is inductor, Q is a resistor, R is also resistor, C2 and C1 is given and P is also given. Here is a 2 capacitor C1 and C2. Okay, and here is the value of P. Value of P will be changed from this to this switch, and the value of resistor R can be changed from this switches. Okay, so let us try to start the circuit. Before starting the circuit, let us connect this detector using connecting wires. Okay, so let us start the switch and just focus on the observation table. Observation table is here. Just Okay, so let us make an observation table. So before this, here I want to measure the value of P. Value of P will measure here, and then value of Q. Value of Q, but the value of Q chosen in the way that Q must be equals to P minus R. So in this way I want to balance the sides, and then for now we want to measure value of R, and then with the value of P, Q, R and C, we can calculate the value of L is equals to P, R, C. Okay, this is our observation table. Okay, here is a P. I want to select capacitor. This is the switch for the selection of capacitor. This is the switch for selection of capacitor. So I want to choose first capacitor. This is the C1. This is the C1 capacitor. Okay. Now I want to select the value of P. 300 ohm. Here unit is given, it's multiplied by 100. That means unit is given, it is a 300. Suppose P is 300. Suppose P is 300, then Q must be equals to P minus R, and the value of R is 75 ohm. What is the value of R? R is 75 ohm, and the 75 ohm is the resistance of this unknown inductor. This is the unknown inductor. The resistance of unknown inductor is already given, and it is a 75 ohm. So suppose this is 300 and this is 75. That means my value of Q must be, the value of Q must be 225. That means it is simple calculation. That means 300 minus 75 is 225. Okay, this is the value of Q. It is a 225. So let us place the value of P. It is a 300. Okay, and then value of Q, it is a 225. Now I want to select value of R in such a way that my detector come back to 0. My detector come back to 0. Let us come back to the original condition. That means it is a 0, 0, 0. Now I want to select the value of this R. Using these three knobs, my detector should be show me 0. That means let us try to go towards the 0. It's a 0.53. It is 54. It is 1.34. That means it is too high. Okay, it is 0.53. Let us do from here 0.26, 0.13, it is 0.02. It is very near to this 0.00. That means what is the value of R? It is 3000 from here and 400 from here. That means it is a 3400. It is a 340. That means it is a 3400 ohm. It is a 3400 ohm. And what is the value of C? It is a 0.1. It is a 0.1 microfarad. Now let us calculate the value of L. Now let us calculate the value of L. That means L is equals to, just wait. Okay, L is equals to what? L is equals to P R C. What is the value of P? What is the value of P? P is equals to 300. So let us place 300 cross. What is the value of R? The value of R is 3400. It is a 3400. What is the value of C? It is 0.1 into 10 raised to minus 6 because it is in a microfarad. Because it is in a microfarad. Let us check using calculator. So it is a 300 multiplied by 3400 multiplied by 0.1. This give me 102,000 into 10 raised to minus 6 Henry, because we are using SI unit, and 10 raised to minus 6, that means 1 2 3 4 5 6, it's a 0.102 Henry. So you can write in millihenry, that means 102 millihenry. L is 102 millihenry, but I know that my inductor is of 100 millihenry, but it is very near to 100. So in this way you can perform 3 to 4 another readings. You can perform 3 to 4 another readings for C1 and another for C2 also. So in such a way you can calculate or you can determine the unknown inductance by this inductor. Okay.